Hello, everybody. My name is Giovanni. I'm the technical lead for System Web Apps, and I'm gonna talk to you about what they are, a little bit of the background of why we have them, and end up in going through like a short summary of how you can build a System Web App. Um, so make sure that you go to slido.com where you can post any questions as they come up, and I'll answer them as they come up. Yes, it's just an overview of what we're going to go through, just a background of how we came to build the System Web Apps platform, why we needed it. Then we'll go into a bit of detail about what exactly are System Web Apps, what are they built, what technologies they are built on. Then we'll talk a little bit about how to build one, very high level overview. But there's going to be links to different CLs that implemented a System Web App, so you can use those later if you want. And we'll leave some time for questions at the end. So let's start with the background. So Chrome apps had been sunsetted for a while, and it was clear that they were going to be deprecated at some point. But unfortunately, we have a lot of apps built that ship as part of Chrome OS that are built using Chrome apps. Things like the gallery, camera, text, even the feedback menu are built using Chrome apps. So we needed to build or find a replacement for Chrome apps for these apps. Since Chrome apps were started and these apps were built, the web platform has come a long way. We have like very powerful APIs for like Bluetooth, USB, file system. We have WASM for performance critical things. So we thought that was a good starting point for this new platform for apps. Unfortunately, the web doesn't have enough. Didn't really have all the APIs that system apps need. Things like access to all of the files, notifications, stuff like that didn't really make sense on the open web, but are critical for system web apps. So with all of that context in mind, we had a couple of goals for the platform. First of all, we wanted to use the web. The web is the main platform for Chrome OS, and it's still, even though it has some drawbacks, it's still the best platform for building UIs. We also wanted to use as much of the web platform as possible. So things like service workers, just workers in general, all the new web APIs, all the stuff, so that we could have a long-lasting platform, a stable platform, but also reduce the maintenance costs on the Chrome OS team. We didn't want to maintain something as big as Chrome apps since we don't have as many people as the Chrome apps project had. Or we don't have as many customers as Chrome apps either. The third goal was that we needed access to powerful APIs that don't really make sense on the open web or are maybe too dangerous to expose to the dry-by web. So things like directories, special directories, camera access, all these things that don't make that are and even like things like setting a wallpaper, for example, don't really make sense for the open web, or they might take a long time to come to the open web. But we need them today for Chrome OS, since we already have apps that are doing those things. And lastly, we needed a way to support processing of untrustworthy data. By that I mean things that are not shipped with Chrome OS, things that are not written by Chromium developers. So like images provided by the user, content downloading from the web. Up until now, we didn't have anything that's part of Chrome that needs to process untrustworthy data. So we needed to build something here as well. So with those goals in mind, we came up with a new platform and we called it System Web Apps. System Web Apps, in short, are essentially web apps with extra APIs. Web apps or PWAs with extra APIs. So these are the different parts that make up a system web app. The web part of the system web app. We decided to go with Web UI in this case. For those that are not too familiar with Chromium, Web UI is the stack that we use to build UI surfaces using web technologies like HTML, CSS, and JavaScript. Things like the history page, settings page, bookmarks, all of those use Web UI. We'll go into a bit more detail about that later. The app part of the system web apps is built on top of the improvements that the desktop PWA's project brought to the app UI. So, for example, they revamped the app window, so we reuse that app window. They have better icons on the shelf. All that stuff that was part of the desktop PWA's project, we use it for system web apps as well. For APIs, we use Mojo. Mojo is an IPC system that we use throughout Chrome, from Blink, the renderer, up to like daemons and all, and like really low level stuff. Anything that uses IPC can use Mojo. So we decided to go with Mojo, and the main reason was that it already provides a good C++ API for people to implement their APIs, and also generates some JavaScript bindings that the apps can call from JavaScript to use the APIs implemented. For the system integration part of the apps, that's sort of done as a case-by-case basis by the teams that own the apps. So, for example, the settings team added a button to the shelf to launch the OS settings. The help app team changed the shortcut to launch the system web app, and stuff like that. That is done by each of the teams, and since system web apps is really flexible, they can do that pretty easily. And the last part is the entrusted context or content. So things like Web UI and Mojo were built with the assumption that they were never gonna be touched by untrusted, by code that processed untrusted content. So by default, they are very, very loose and don't have a lot of security constraints. This was a problem for system web apps because a lot of the system web apps need to process some sort of untrusted content. So, for example, the media app needs to be able to render images and video files, and we can't do that in the same process the same process that we grant access to the file system, for example. So we needed to come up with a solution to that as well. So let's dive into a little bit more detail about each of the things. The web and system web apps, as I mentioned before, we use Web UI for this. A lot of Chrome pages are implemented using Web UI, so it's a good fit for system web apps. You can think of Web UI as the server of the page, of a Chrome URL. It basically has a URL data source that contains all your resources, all your HTML, your JavaScript, your CSS, and you register that Chrome that URL data source, and when you navigate to the Chrome URL, we serve those resources. So this is not specific to system web apps. This is just something that is available to all Chromium developers. Anyone can build the Web UI. Next is the apps part of that. As I mentioned before, we used a lot of the things that desktop PWAs brought. In the picture here, you can see the two app windows. On the left is the system app. In this case, is the help app. On the right, it's the Canvas app. Canva's web app. You can see they're very similar. They both have their own icons on the shelf, but the system web app is missing the three-dot menu, which doesn't really make sense for system web apps. It's also missing the origin, because again, that doesn't make sense for system web apps, and also missing the extension icons, since extensions are disabled inside system web apps for security reasons. Um, the next part of the system web app is the APIs. Specifying APIs for system web apps is pretty straightforward. You create your Mojang interface. In this case, this is the Mojang interface for the help app. It has an open feedback, show parental controls, and another method to know if a search service is enabled. Once you implement that, you expose it to your app, and then you can see in the on the lower right here the methods that you can call from JavaScript to call this interface. The last part of system web apps is the untrusted processing untrusted content. So this as I mentioned before, Chrome pages were built with the assumption that they were like an extension to the browser process. So they were very high privileged. They had access to any APIs that they wanted. They get default granted a lot of extra capabilities. And this was an issue for system web apps, because we can't be processing untrusted content in this context. If the untrusted content is able to exploit a bug in the renderer or a bug in the app code, it could get access to all these capabilities that we grant to Chrome pages. So we needed to find a solution for that. And the solution we came up with was to introduce a new scheme. We call it Chrome Untrusted, which is the same as Chrome, but it just doesn't get default granted any capabilities. Untrusted, we ended up with calling it Chrome Untrusted because we wanted a really scary name to signal developers, Chromium developers, that this page that you're reviewing is processing untrusted content. So you should be careful with whatever it is that you're doing there. It doesn't mean that the page is dangerous or that the user might get compromised or anything. It's just a signal to us Chromium developers that we have to be careful with that page. That's why we actually hide the Chrome Untrusted scheme from a lot of UI surfaces, because it doesn't make sense for the user. It's more of a developer thing. So what is Chrome Untrusted? As I said, it's just a different scheme, same, also backed by Web UI, but doesn't get granted any capabilities. It serves as a technical and semantic boundary for apps. They can split their apps into a trusted component, or we call it a trusted context, and an untrusted context. In the trusted context, you get access to all the APIs that you want, like file system, camera, all those things are done in the trusted context. And inside your untrusted context is where you process all your untrustworthy content. So you could, for example, imagine the media app has all its UI in the trusted context, but in the untrusted context, they just render the image. And this like helps since this is an iframe, it's rendered in a separate process, so there is no risk of that image compromising the trusted context. And lastly, we have this communication channel currently uses post message, so that the developers can send data across the trusted context and trusted context boundary. Yeah, so that's mainly it for the parts of the system web app. So we'll just go quickly over how to actually build a system web app. This is a very high level view of how to build a system web app. But there are links in the presentation. I think we'll be publishing the presentations later, but where you can see what the CLs in more detail that actually implement these things. So there are basically three steps for building a system web app. The first one is to create a web UI page, just like a regular Chrome URL that has some UI. Then you have to add the app or the page to the System Web App Manager. System Web App Manager is this class inside Chrome OS that just installs installs the apps. Just like a user goes to a web page and installs the PWA, the System Web App Manager does exactly the same. It navigates to the URL, installs the app. And lastly, you create a modular interface, you implement it, and expose it to the System Web App. So the web UI part. So the like two big pieces of web UI are the web UI controller and the URL data source. The web UI controller is just a class that gets constructed when someone navigates to the Chrome URL. So you just create one of those, have it create a URL data source with your resources, and then you register that web UI controller so that when someone navigates to your URL, we initialize that web UI controller and we serve the resources from the data source. You can check there, we have a CL and that does this for the print management app. All the CLs that you're gonna see in the slide are from the print management system web app. The next step in building your system web app is the installation part. As I mentioned before, this means adding your system web app to System Web App Manager. So maybe you've heard from PWAs that they have a manifest. System web apps don't have a manifest per se, but they do have a web application info, which has the same fields as the manifest, but it's just a C++ object that we can just hard code in the code. And it avoids us having to like load a renderer, parse the manifest, and all that stuff. So you just create a web application info that has the metadata of your app, the icon, the app name, the start URL, all that stuff. And you add that to the System Web App Manager, which will handle installing your app when Chrome OS starts up. And the last part of the building your system web app is just exposing APIs to it. Yeah, this is just like exposing any modular interface to any part of Chromium. You define your module interface using module IDL. You add a method to your web UI controller so that the calls to your interface to requests, so like JavaScript requests to your interface get bound to the implementation of your interface. You register this bind method in the binders map. The binders map is just a huge map of interface requests to binding methods. And lastly, you add the generated module bindings, so the JavaScript that you will call to your URL data source. It's basically your API library to your data source so that you can call it from JavaScript. And that's it. That's like the three easy steps for building a system web app. I think that's it for system web apps. I don't know if people can go to Slido and ask any questions. I'm happy to answer that. Any questions about system web apps, the context, what type of system web apps we have. Happy to talk about any aspects of it. Okay, so I have a question here. Can third-party developer build custom APIs that are exposed to Chrome and trusted? Are these APIs proprietary? So in the context of system web apps, it doesn't really make sense for a third-party developer to build APIs. These are apps that are shipped with Chrome OS. So these are mainly built by Chrome engineers. You could fork, if you build your own version of Chrome OS, you can implement your own system web app and add any APIs that you want there. So this is more of a platform target for Chromium developers more than to third-party developers. Cool. There don't seem to be any more questions, so I think we can end up early. Thank you for coming and listening, and have a good rest of the day.